let's complete the square. Now, for this time, I am not going to write our 5 steps out to the side. Hopefully, you're starting to get used to those 5 steps. I will talk about them as I go, but I'm not actually writing them over here on the side of the problem. So, step 1, gather our like terms. I have x squared minus 2x. I have 4y squared plus 24y. And I have a 33. And it already equals 0, which is what I want. Step 2 is to get the x squared and the y squared alone. The x squared is already alone. Fantastic. So let's get the y squared alone. Step 3 was to move the squared to the outside. And then cut the last number in half. So this is a -2. Cut that in half, I get a -1. This is a +6, cut that in half, I get a +3. And step 4 is to FOIL everything out. This gives us our check step. And it also helps us know what we need to get rid of. So FOIL this out. X squared minus 2x plus 1. I'm going to leave the 4 out and just FOIL those together first. Y squared plus 3y is 6y. Plus, 3 times 3 is 9. Then distribute the 4 in. 4y squared plus 24y plus 36. So here's my check step. Make sure that you are matching what you started with. Check. And now I can get rid of the extra. I have a +1 I want to get rid of with a -1. And I have a +36 I want to get rid of with a -36. So this is my completing the square. Let's rewrite what we've got. X minus 1 squared plus 4y plus 3 squared plus 33 minus 1 minus 36 is actually -4 equals 0. Now remember, at this point you have technically completed the square. But from here on out, it's about getting the equation to look like the shape we want. We're dealing with ellipses. By the way you can know from the equation up here that this is an ellipse is first off, both x and y are squared. If only one of them was squared, that'd be a parabola. Second, the numbers in front of the x squared and the y squared are different. If these were both a 4, then this would be a circle. Or if they were both a 1, this would be a circle. So because they're both squared and the numbers in front are different, that's how we know this is an ellipse. Now, to get this equation to look like an ellipse, first thing I need to do is bring this 4 over. Now, the other thing you should remember about the ellipse equation is it always equals 1. That's what it should always equal. So the next thing I'm going to do is divide this by 4 to force it to equal 1. But if I divide that by 4, that means I need to divide everything by 4. So now I have x minus 1 squared over 4 plus, those 4's cancel, so I have y plus 3 squared over 1 equals 1. And ta-da! That looks like an ellipse equation. So I'm going to come up here, copy my ellipse equation down. And now I want you to pause the video and use this equation to practice graphing. We have done this quite a bit at this point, so you should be pretty good to pause this and try this out on your own. I will finish writing these out. So now you can use the equation we got, find our 6 things, and graph it. Pause the video, try this out on your own, and then come back to check your work. Let's see how you did. First, I found my center, h and k, and flipped my signs, 1, negative 3. Then my major axis is whichever denominator is bigger. So square root of 4 gives me a major axis that is 2 long in either direction. And I know that it goes side to side because it's paired with the x. And that is at the y equals negative 3 line. So that gave me my vertices points. Minor axis is square root of the smaller one, which is 1. I know it's up and down because it's paired with the y. So up 1, down 1 gave me my co-vertices, and that is at x equals 1. Then I plugged it into my foci equation. Major axis squared minus minor axis squared gave me square root of 3, which is 1.73. Needs to go on the major axis. So that is 1 plus square root of 3, and then my y value is negative 3, and 1 minus square root of 3, y value is still negative 3. And there's our ellipse. So that is all we're going to do today with completing the square. In the next video, we're going to introduce the idea of eccentricity of an oval or an ellipse.